Yeah, okay. All right. Well, I reckon we can get started. Let's learn about Docker, Azure, and PowerShell. I'm really anxious to know if any of you are using containers now. Any of you messing with Docker at this point? Good. I'm glad, because that means that you'll learn something new. All right, so what I thought about in planning this for our session tonight, what is Docker exactly? I mean, you see it all over the place on the news. It's like, what the heck does it mean? What does it mean for us as Microsoft professionals? Why should we care? The next bullet point, it's behind this blue screen. It says something like how to do Docker containers in the context of PowerShell. And I think if memory serves, that I can actually read it on my screen. How Docker integrates with Server 2016. That's a big deal right there. And then how do we spin up Docker containers in the Azure cloud? So those are the 3 touch points for tonight. The session files, as usual, I've got them on my website. So it's timwarnertech.com docker-nashpug.zip. I've got the slide deck. It's in PDF format. That's a typo. And the PowerShell scripts are also in that archive. I'll put that up at the end of the presentation as well. So first, what the heck is Docker? Well, before we define Docker, what problems does Docker supposedly solve, really? I mean, it's one thing to talk about a buzzword, but it's another to understand some of the problems. And a lot of these are really DevOps-y developer problems. The problem of spinning up application services for developers who may need to bring up a pod, a multi-tier, like a web server, a database server, and an app server. Do you have System Center going? Are you using Azure? How quick is it to spin up heavy VMs? I would guess not very quick. What's another problem? VM scaling and portability. Your website experiences a spike. Azure is good on its side at spinning up new VMs, but how about if you're trying to do the same thing in your data center? Again, heavy VMs, they require a lot of time. VM snapshotting, the idea of rolling back an entire VM easily if you need to do that. And then, of course, just the concept of virtual machines tending to be thick, heavy, take a long time to transfer, take a long time to back up. And there's the security issue, right? Because a VM is the same thing as a physical box. So if that machine is not secured properly, the attack surface is much wider than perhaps it could be. So those are the big problems that Docker attempts to fix. And it's interesting when you think of the brand Docker and the name, I immediately think of shipping containers, and I think that's really the point. I mean, the idea here is, evidently before World War II, shipping containers were all non-standard. So you can imagine manual loading and unloading of all these odd-sized containers. It's not efficient, it's not fast, it's not agile. And I learned, thanks to Wikipedia, that after World War II, the standard shipping container became standard. And no matter where you are, as long as you're accounting for that standard form factor, you can completely automate the process, So that metaphor is what informs the Docker product. So what are some facts about Docker? It's an open source technology. The project's up at GitHub. The container, it's really a virtualized application. I mean, have any of you done stuff with like AppV? Have you, Mick? Do you still use AppV?
No.
No, what were some of the problems or good things about it? AppV, of course, is where you can package an application and stream it to your users. So everybody might be running IE10, but you have a line of business app that won't run under IE10. You can package IE6 or 7 and stream it to your users. Is that what you were doing?
Well, the problem that we had with it was the fact that if it needs to communicate outside of its sandbox with other applications, that was the problem.
Yeah, because those are, of course, those packages are intended to be sandboxed. Exactly. So these containers in Docker are applications, services, potentially an entire VM that exists as its own isolated entity. Docker is open source and therefore tied with Linux historically. Any of you familiar with chroot or chroot JALs, where you set up an FTP server and the user comes in and what they see as root is not the root of the server. I mean, or if you have a web hosting account, you log into your directory. As far as you're concerned, that's your whole world. but really it's just a directory among hundreds on the server. You've jailed the user to a particular location. Again, the idea with containers is that your applications and services are jailed or protected from each other. But the nerds will tell you, the Docker nerds will tell you that Docker doesn't rely upon chroot at all. It's a different thing. So again, the theme is these Docker containers are much lighter, faster, more modular than full heavy VMs. Some advantages: lightweight footprint, because you're not taking a whole operating system. I mean, think of Windows with the GUI and with the Windows updates and with your applications and drivers. Here, you're running an instance of an application or service on a host OS, but it's sort of riding on top of it. So like if you have a single server that's hosting like 10, 11 Docker containers doing different things, maybe web services, database services, app services, those containers are isolated from each other, but they are sharing kernel resources and they're sharing resources on the underlying hardware host. So these containers aren't, as watertight, I guess, as you might think initially. Again, they offer supposedly higher security because you're isolating applications. Really, agility seems to be the biggest thing with these containers. You can essentially just copy them across the network, and because they're just a fraction of the size of a VM, it's going to be much more efficient to do that. You're familiar with version control. Brandon, you've got the GitHub Octocat on your laptop, so you're familiar with it. The idea of version control, committing and rolling back and all that kind of stuff, you can do that with these Docker images. So if there's a problem, it's just literally, it could be seconds to roll a container back to a previous state. Think of doing that with a heavy VM that you've snapshotted. This Docker thing is meant to support rapid application deployment. Again, the idea is a developer may need to test something, whatever that something is. They can spin up web servers and database servers literally in seconds. I already mentioned version control and reuse. Okay, disadvantages to Docker? Well, there's a few. One, like I said, these Docker containers are sharing the host's operating system kernel and resources. So it's possible that exploits could trickle down through the container to the host that it's running on. It's not absolutely foolproof. It's interesting how Docker does its virtualization, though. It's part of the Linux kernel that evidently it can virtualize, just like a VM can, hardware. So your containers can have their own IP address. They can have their own file systems that appear just local to that box. I mean, they act kind of like VMs in many ways, and you'll see that in the demos in just a moment. It is a weaker isolation than VMs because, like I said, there's that sharing aspect. Dependencies, like Mick is saying. If you have a container that relies upon resources from another container, you can actually combine Docker images into a single, like a monolithic container. So if you had an N-tier application where you had Nginx web server and MySQL and some other service, you could build a container that integrates all three of those. So you can resolve some dependency stuff, but that may limit portability nonetheless. Potential for sprawl. Some developers and shops think, my gosh, it's so easy to spin up these new containers, you wind up with more than you can manage over time. So that's definitely in the disadvantaged category. Limited tool set. I think what that means is that when using the Docker ecosystem, there's a series of commands that you'll learn about in just a moment. And Windows PowerShell has an interface to Docker, but there really isn't a huge amount of third-party buy-in yet. But I'm sure that'll change going forward. Okay. What's this show us? This shows us the basic architecture of Docker. Basically, you've got your Docker runtime environment. Your daemon, as the Linux Unix people say, that runs on a hardware host. Okay, that's going to be your container server. You manage that server either locally or remotely using the Docker client, and the command line tools all start with Docker something. Docker start, Docker stop, Docker ps, Docker run. And you use those Docker commands to do all of your image creation and maintenance. I don't think I get into it in here, but basically the workflow for creating a Docker image, you create what's called a make file, which is essentially a build script. and then you create what's called an image. And the image is kind of like your golden master. In programming, you'd consider the image to be like a class. And then you use Docker run to create instances of that class. So you might have a class for your 3-tier application, an image for that. And then you can just spawn as many containers off of that as you want to. And you'll notice the third piece over there, the Docker registry. There's a there are several, I guess, public repositories where you can browse and download Docker images that other people, community members have built. You know, it's a typical open source deal there. All right, questions, comments, concerns thus far?
So Docker basically compared to like AppV, Docker has, from what I'm gathering here, it uses more the operating system. It's not so closed off from everything else.
Right. Yeah, it's not anywhere near as tight and constrained as AppV or Citrix. Also has a app virtualization product. I always forget what it's called. Does anybody know?
XenApp.
Yeah, XenApp, exactly, right. Yeah, Docker strikes me as a much more open and flexible architecture because like I said, when you create your make files and build your images, you can pull a lot of different applications and services together. It's not just one and one.
And the problem I think it's going to be horrible before it actually gets decent with things like Docker, because it's like, you know, it's hard enough to manage your dependencies and stuff, but then you take everything and you just put all the dependencies in these little containers and then, you know, trying to figure out, you know, oh, well, this container's from them and they're not updating it, so now you got to figure out, I have to manage all these little containers that you might be pulling from whoever, from wherever.
Exactly. Remember when we learned about package management several months ago? Similar kind of thing there, where there's the PowerShell gallery, where you can download packages for PowerShell that people have created, and who knows how often they're updated, who knows how complete they are. And you can also, if you want to, alternatively have your own internal PowerShell package repository where you would have full control over what's there and what's not. Same thing goes with here. We don't have to rely on the public Docker repositories. You can create your own internal repo that has only images that you fully control.
Well, I know not long ago there were people that were going over all the images in the Docker repository on the like official one, and like huge portion of them had vulnerable, like really bad vulnerabilities built right into them.
I believe it. It's buyer beware, right? Caveat emptor, I think I learned in high school. Yeah, just because it's on this official repo doesn't in any way, shape, or form say that they've been checked or whatever. Okay, so Docker integration with Windows. This really gets interesting stuff here. Not in the current version of Windows, but in vNext Server 2016, we have built-in support for Docker, and you're going to see that in just a moment. Microsoft has really embraced open source. It's kind of crazy, and they've got a lot of repositories at GitHub, and they've forked the Docker project. That's what you're looking at right here. And evidently, from what I understand, it's not so much porting the Linux project. They're doing a lot of full rewriting. Because when you think about it, the Linux kernel and the Windows kernel, I mean, they're totally different. They're not going to work together directly. So Microsoft, in conjunction with the Docker people, they're working directly together, are recreating the Docker engine, the daemon, in Windows, and have done so. It's pretty rough and it's pretty slow. It's certainly not anything that's anywhere near production ready at this point, but it's enough to where I can show it to you and we can kick the tires. So what this picture is showing is that, like I said, Microsoft has created a client, the Docker engine, that runs in Windows, and we can create honest-to-goodness Docker images that potentially can run anywhere. Although this is showing you, like I said, the operating system kernel differences are such between Windows and Linux that you'd need to, for instance, do Docker on a Linux box to create a Linux container. With Windows Server, we're going to be limited to Windows containers. That probably makes sense. Probably wondering, well, what kind of containers can we create? This picture shows us, let's see, what is this saying here? The left part here is showing us the hardware box, the container host. And this container host could be a machine in our premises or on the public cloud or whatever. And it's showing us that we can go in a couple different directions, like I said earlier. We can build a Docker image that virtualizes just an application. This example is MySQL. And the container view, as far as that container is concerned, it's running an instance of MySQL and has network access and is acting like a real live database server that's on your network. But Windows is allowing us to build Docker containers for the entire operating system. Now, it's not a VM. It's not the whole replicated virtual machine, but you're taking all the OS bits and packing it in one of these containers. It's weird to kind of wrap your mind around it. At least I think so. You see there that we have some choices here with these Docker Windows containers. Whoops. Did I step on something and create that? I hope not. We can do server core, you can do server with a GUI, or you could do Nano server or Hyper-V. There's a few roles that Microsoft is supporting right now for the Windows-based containers. Hyper-V, of course, would be good because then you could have honest-to-goodness Hyper-Vs hanging off of a Windows container. Again, it's kind of weird to wrap your mind around. This is just a screenshot from Windows Server 2016 that shows you installing the container feature from the GUI, which is kind of interesting. How this fits into the Azure cloud. Basically, the integration is this. In the Azure gallery, you can bring up a virtual machine running Server 2016. It's technical preview 4. TP3 and TP4 have the container support. As of today, technical preview 4 is the latest and greatest. You can download it from the Microsoft website, or you can spin up a VM in Azure. I have both available for us right now. And that's really it. It's time to whip out some virtual machines and some PowerShell and see how this goes. The demo architecture is this. You see, in my Azure account, I've created a virtual machine running Windows Server 2016 TP4, I think, not that it matters, that has the built-in Docker daemon. And then on that system, we'll create one or more containers that can in themselves run Windows Server 2016. Like for instance, we can do Nano server. How familiar are you, any of you, with Nano right now? A little bit. Have you gone beyond reading about it? Have you kicked the tires at all with it yet? No? Okay. All right. Okay. Don't need summary. Okay, so what do we have here? Let's bring up my ISE window. First, I don't know why I have this here for us. We can look at this or we don't have to. I give you the script either way. But if you're interested in bringing up an on-premises Nano server just for the heck of it, this is some PowerShell that can help us do that. I'll just quickly walk you through the code when the video comes back. And I've actually got an instance running on this machine. Okay, I've downloaded the TP4 ISO, and we can mount it using mount disk image. I don't think I've done that yet, so I'll do that now. And then I've plucked a couple PowerShell files from that ISO disk image, or I will need to do that. One is a module called Nano Server Image Generator, and then we can get commands from that module. Let me quickly run that code.
Scripture set. You're in C.
Pardon?
You want to be in C Nano.
Oh, yeah. Okay. And basically what this looks like, let me show you the Windows Server DVD. Microsoft, I don't know if they're going to make it more obvious how to install Nano server once it gets closer to release to manufacturing. But right now, you actually have to do some extra work to get Nano. There's a folder called Nano server. And basically, you've got your Nano server image generator module. And then there's a PS1 file called convert Windows image. And as you can see here, we've got just 3 commandlets in that Nano server image generator module.
Seems kind of crazy that you have to download the big, huge Windows Server ISO to get the little small thing.
Right, because in Nano, the word Nano, of course, means tiny, and the idea behind Nano server is it's this microscopic, tiny little footprint server. I think the idea is, and if you look at the source code of that, those commandlets, Nano gives you so little, you have to inject anything you want on it. In other words, all your Windows roles and features aren't in Nano. You have to get them from the media. And that could be a file share, or you could pull it directly from the DVD. So these commandlets that you use to build a Nano server are actually pulling from the rest of that DVD image. So that's what I did here. New Nano server image. I supplied the media path as the DVD. It'll create a folder called base in your present working directory. The target path I specified is a subfolder called Nano1. It should really be called Nano2 because that's the name of the VHD. Basically what this process does, this new Nano server image does, it builds a VHD virtual hard disk file that has Nano on it. It's as simple as that. It weighs in at around 700 or 800 megs. And when was it last that Windows weighed in at 700 or 800 megs? Was it Windows 95 maybe? Or was it earlier than that? When you attach that VHD, you wind up with a local running Nano server, which looks like this. Originally, in TP3, there was nothing at all. If you tried to access a Nano server locally, there was just like a blinking cursor. But I think due to customer feedback, the team is now giving a really stripped down interface here. So let's see. Administrator, my password.
So that must be partially why it's bigger than what they had originally said. Because originally, I remember Jeffrey said it was going to be like 450 megs.
That's right, yeah. In fact, Jeffrey Snover had said at Ignite, actually, that he wanted Nano to just, if you tried to log on locally, he wanted some ASCII art saying, get away from here. It's not supposed to be there. Because he so strongly believes that a server should have no GUI, that it needs to be remotely managed. And the only time you should ever have a server with a local GUI is for backward compatibility, if you absolutely need it for some reason. So Nano gives you this. It reminds me a tiny bit of Windows Server Core sconfig. I mean, basically you just have your core metadata up above, and you can tab down to look at your networking and set your static. By default, it's going to do DHCP, of course, but you can override that with a static IP configuration. There's a whole bunch of built-in firewall rules, which make sense, especially for PowerShell remote management. The remote WinRM stuff, the firewall rules are already enabled by default because, again, the whole idea behind this Nano server is that you need to remotely administer it. So this is a Windows Server 2016 technical preview machine. And let me quickly connect to it. I'll open up a console. And then we'll do Docker. We boost the font here.
Did they by default install Candy Crush and stuff on the server 2016?
You know something?
That's another thing that's annoying.
I don't know. I would hope there's no games on it, but you never know.
Finding Windows XP sounds and Windows Server.
Yeah.
Well, I
I
know the consumer experience, like 1511 group policy that they added is disabled by default. So by default, you get the consumer experience, even on enterprise, like enterprise or whatever. Which means, I remember when I got first machine got 1511, I'm like, is that Candy Crush that just got installed? And then Twitter got installed. Like all these apps started getting installed. I'm like, okay. There's
They're doing some wrong update here. Someone's taking over my system, and I don't appreciate it.
Okay, well, it can actually be a kind of a booger to join the Nano server, the Nano machine to a domain. You have to use offline join. using djoin.exe. You have to harvest a blob from a server or a machine that is on the domain. I've got the PowerShell in there if you're really interested. But basically, I'm going to create a live connection, a remote session to that machine with enter PS session. And because the machine's not in the domain, I'm overriding and specifying a local credential, which is administrator with my original password that I set up Nano with. And then from here, once the connection goes through, it's like any other PowerShell remoting thing. I can manage rules and features, I can inject stuff, and that's the idea, I guess, with Nano Server. It's just a much smaller footprint, much smaller environment. There we go. So we're connected now to the Nano box, and we can do whatever we want. All right, that's that. I don't think there's anything else we need to mess with that. Let's go to the Docker stuff. All right, what I've done is in my Azure account, in fact, I better authenticate so this actually works. Are any of you using Azure in business at this point?
Not me personally.
Or Amazon or any other public cloud?
We're using a lot of Amazon. I think we settled on Amazon as our standard, which is ironic because we purchased the company and all they do is deploy on Azure.
Oh, yeah. The thing that's kind of annoying about Azure is that they ship new features literally every day. So you'll be accustomed to doing something one way and then find out that it's totally changed the next day. It's really annoying. And one of the things, but it's a good thing, is that they gave us a command called add Azure account that gives you this little login thing. It used to be you had to download a management certificate and do a whole bunch of stuff to get connected to your Azure account from your computer. But now it looks to be just one command line. So let me quickly authenticate. Make sure that my subscriptions show up. Yep, they do. Okay, good. Now what we're doing here, although it's in Azure, we could do the same thing in an on-premises environment if we have a local Windows Server machine. It's just two different flavors of the same ice cream, so to speak. What I'm doing in line 6 here is I'm querying the Azure image repository, VM image repository, they call it the gallery. So instead of going through the web portal, I'm going to do this with PowerShell, of course, because that's what we're here to do. And what this line does is it does get Azure VM image. So it's tapping into the VM library, and it's going to pull back any image that has a label including container. And then it's going to do a descending sort on publish date, because we want the most recent one. And it's actually going to go in and grab the specific image name of the most recent image in Azure, if that made sense. So I'll run that line. It'll take a moment, because there's quite a few images in the Azure gallery, as you would expect. And then if I bring that variable back, it gives us a wicked long GUID name, Windows Server Core TP4 Container Azure.vhd. So that's the VHD virtual machine file that we're going to create. And then these lines here, 9 through 12, are going to actually build the virtual machine. And to build a virtual machine in Azure using PowerShell, you just specify metadata in what's called an Azure config. You pass in the instance size, because you know these VMs as a service, it's like you go to an ice cream shop. You want a small, medium, or large cone. You want chocolate or vanilla or whatever. We choose an instance size. We pass in the image, that VHD file that we looked for. There's some other things we need to specify, like which virtual network we want to attach the virtual machine to, what our local administrator name is going to be, and our password. Of course, we'll want to choose a different name for the administrator, because this virtual machine is potentially browsable by anybody in the world. And if they're just trying to hammer going across VMs, trying administrator with a password of what, 1, 2, 3, 4, 5, or a password of password, or a password. Okay, and then finally, ultimately, new Azure VM, blah, blah, blah. Okay, I've actually done all that. So at this point, let me run get Azure VM to make sure that it is, in fact, still alive up there on the cloud. Yep, So the name is container host 1. It's in ready role, which means that it's actually running and we can connect to it. So let me switch windows here. I've got a terminal services connection to that machine. Now this is a server core instance of Windows Server 2016. So all we're going to have is a command prompt. Any of you running server core, by the way? Have you ever messed with it?
Mm-mm.
Yeah, I get to the point where we're installing it, considering, okay, what it would take to use this, mostly for our Active Directory environment, and it had some good things going for it, but it didn't have enough going for it for me to justify the complexity in deploying and maintaining.
Yep. It's interesting how cyclical technology is when you think about it. Because I think in Server 2008, when Server Core first came about, at first blush, it looked like a good idea, but it was an either-or thing. You go to core and then you realize you need the GUI. You've got to scratch and reload. And initially, Server Core was terribly hard to configure. There wasn't sconfig.exe or anything. And so gradually, with Server 2012, you have the minimal server interface where you can kind of step down from the full GUI, or you could go down to core or up. It's really great, isn't it? The GUI layers there. And now with Server 2016, the Nano option. But the cyclical piece is, at least as of today, it's either Nano, Server Core, or Server with a GUI. If you do Server Core, you can go up to Server with a GUI and vice versa. But with Nano Server, if you go to Nano and decide you just can't live within that little environment, you have to scratch and reload to go to Core or GUI. So there's that to consider. So as I said, this is a Server 2016 box, and let's jump down. Let me try to overlap both windows so we can see what we're doing in both situations. Okay, get service name Docker, right. I do have my PowerShell session going, and this is a proof of concept to verify that the Docker engine is in fact installed and running on the Server 2016 machine. There it is. So it's visible just as any other Windows service is. That's good news. Now the Docker commands all start not with Fokker, but with Docker. And if you run Docker help, this is really the same syntax and the same output you get if you do it on a Linux machine. It's really remarkable that Microsoft is so friendly. At least Jeffrey Snover's group at Microsoft is so friendly with the Linux community and Unix community. So you see here we've got commands, very simple commands here, really. Attach, if you have a container already running, you use connect, attach to get in there. PS is used to list containers. Run is used to create a new container. RM, remove. They're very Linux, Unixy commands. But here's an interesting thing here. Watch this. Get command module containers. There's two ways to do containers in Server 2016. You can use native Docker commands if you're already familiar with those, or you can use this suite of commandlets. But, and this is a big but, drum roll please, it's either or as of today. I haven't tested it, but evidently if you build a container using PowerShell, it breaks when you try to use Docker commands. Vice versa, if you build a container with Docker commands, it breaks under PowerShell. I would hope that that'll be resolved by the time we get closer to RTM. But I've been focusing on the Docker command set. But these PowerShell commands, I mean, they're as standard as any other. The standard verbs, gets, adds, news, removes, sets. But like I said, I want to focus on the Docker commands because they're a little bit more standard. Let's see, we use Docker images to get a list of any images that are on the local system. The TP4 preview that is running in Azure has one image there just for you to kick the tires. They call it Windows Server Core. So it's a Docker image. Remember, an image is like a master copy of a container. It's a golden image, so to speak. You can edit it, but it's meant to be sort of like a class. And it will actually give you an instance of Windows Server Core 2016. And like I said, it's meant as a proof of concept. Horsing around I created an IIS instance, a Windows Server core machine that's running IIS, and I named that image Windows Server core IIS. And the source code is in the script file that I'm giving you as well. To bring up an instance of a container, we use Docker run. So let me do a CLS, and I'll do it. Well, first let me do a Docker images one more time because I forgot exactly what they were called. Okay, Docker run name. Actually, I don't want to look at images. I want to see what containers I have on this machine. You use Docker PS for that. And if you add the A flag, it'll show you all containers. If you do a Docker PS, it'll show you only running containers. So let's see. I have 26 hours ago, I ran the Windows Server Core IIS container, and I opened a PowerShell session. I exited it 9 hours ago. That sounds about right. You'll notice that each container has a unique identifier that looks very much like a git commit ID. I'm going to highlight the one for the IIS instance that I have on my machine, and I'll press Enter to copy it to my keyboard, copy it to my clipboard, rather. And let's see, I'll do a Docker start, and then that ID. It should be as simple as that to start that Docker image. And then we can go into attach, and we'll actually see what it's like to go into the image. Okay, so now if I do a Docker PS, it should show that that image is now running, which it does. You'll see it in just a moment. Okay, right here. Now remember I mentioned about 20 minutes ago that it's kind of a head trip to think of all this containerization. It just feels to me so abstract.
As does the screen. Not your fault.
Yeah, the webcam continues to lose focus because the screen going out.
Oh boy. Is there anybody joining us in the YouTube broadcast? Really? Well, welcome those of you who are attending. Sorry about the blue screen of life. Or the blue screen of patience. How's that? But like I said, the abstract thing with these containers, they're just so ethereal. They're so abstract. It's like if you didn't know Docker PS, you wouldn't even know that you have this web server running. Well, how can I test or verify that there is, in fact, this web server running? Well, what we can do is simply open a browser, and I'm going to type the URL to the virtual machine, the Windows 2016 Azure virtual machine. It's west150.cloudapp.net. I know that because I've been testing. I think that's what it's called. Maybe it's 150 West. 150 West. Cloudapp.net. Something like that. When all else fails, you can log into the management portal to verify it. Another thing that they're doing at Azure, they have been doing, is they totally revamped the web portal interface. And again, it's one of those things where personally, I'm much more comfortable in this. This is their classic management portal, but their new HTML5 portal's got a lot more bells and whistles attached to it. But personally, I'm more comfortable with the old one. Let me go over to virtual machines and select the container host. What I'm trying to get is the DNS name of the VM. So it is west150service.cloudapp.net. Okay. west150service.cloudapp.net. And what we should see is the IIS page. Yep, we sure do. Because that container that's running in the Azure-based VM, all it's doing, what it's virtualizing, is the IIS server role. And I don't even know if it's got ASP.NET on it, but it can. And as you know, IIS will display this page by default. So I guess you'd call that a proof of concept. If we want to attach to the container and actually poke around it a little bit, we do Docker attach, and then bring in that little GUID there for the, probably, I don't know if this will give me what I want. Let me Control C. No, I guess that would have worked. It put me into a new PowerShell session. Nuts. Now I'm kind of hung up. I don't know what machine I'm on. It's another thing I've observed playing around with this. It's difficult sometimes to know whether I'm in a container or in the container host, because both of them report the same host name. The container host is 01 is the name of the VM itself, not the container. Let's see what happens if I type exit. If it takes me to another PowerShell prompt, then I know I was in the container. If it kills the machine, okay, so I must have actually been in the container there when I did
So didn't
Docker attach. You see what I'm saying?
Didn't a minute ago, didn't the command prompt have like the name in brackets?
I think you're thinking of earlier when I was remotely managing Nano.
Oh, yeah.
Yeah, because I've got local VMs here. I've got a VM running Nano server and another one running the full Windows Server 2016.
I would think the same concept would be good for the containers, so then you know what depth you're in or what, where you're at.
I agree. It should give you some kind of visual indicator so you know where you're at. I completely agree. Yeah.
Or even something like nested prompt level, right?
Something.
Yeah,
'cause
exactly.
You mess around and mess some stuff up thinking you're in one container when you're in another one.
You're exactly right. You're exactly right. In fact, I'm going to submit that as feedback. I need to make a note of that.
Just tag that with @Noxygen.
Indeed.
I'm on GitHub.
You've got credit coming to you.
So that he knows when he goes and makes the contribution to the public Docker repository.
There you go.
That's it.
Where it
Really.
came from, obviously.
Yeah, so even this on-premises machine, like I said, the same thing that we've been doing in the Azure VM is exactly the same here on this local one. We have Docker. Let's do a Docker, I believe it's a dash version? Or is it just dash version? Whoops, I'm on the Nano machine, aren't I? That's another thing about Nano that's important to understand. Because Nano has such a tiny footprint, there's not even a full .NET framework environment on it. In fact, it runs what's called Core CLR. Have you heard that term or read about it in the tech news? It's essentially a portable, stripped-down version of the .NET framework. And the idea is Microsoft and the community are porting Core CLR to all sorts of different other OSs, Linux, Unix, OS X, even switches, routers, and networking devices. So feasibly, the idea is we can use PowerShell technologies like desired state configuration to do configuration on non-Windows boxes. That's pretty cool. And so that's what Nano has, it's just the core CLR. So that means we don't have the full PowerShell core library. There's a subset of PowerShell in Nano, and there's a subset of the .NET framework as well. So let me break that remote connection to come back to the local machine. And now I should be able to do a Docker version to check the version. Maybe I didn't load the containers feature on this machine. That's probably what it is. But it's saying it doesn't recognize Docker, which of course tells me that it doesn't have the containers feature. So let's see. Let's come back to our code and see if we missed anything. Okay, we'll just look at line 49 when it comes up in a minute. Another Docker verb is run, and run is used to spin up a new container. It's as simple as that. As long as you have an instance handy, or an image handy, you can bring it up. Docker run, the name of the friendly name, rather, of the container. IIS demo is what I call mine on this. IT means that you want an interactive session with the container. There's another switch called -P that deals with port. First 80 would be the Azure virtual machine or the container host's port, and then you're mapping that to the port that's on the container. It's sort of like at home when you do port forwarding. It's a similar kind of thing. In this case, I wanted, because I was going to have the container run IIS, I wanted calls to the Azure VM on port 80 to go into the container. And that's all you have to do to make that kind of mapping. And then the last part of the command is the name of the image. And then finally, what kind of environment you want to be on. In fact, we could do this right now, as a matter of fact. Spin up another instance of that IIS demo, and then CMD will spin up an instance of cmd.exe, or I'm going to change it to PowerShell. So that'll connect us to a PowerShell prompt in a new second container running that IIS image that I created.
So is that saying start this container with whatever executable and launch whatever executable?
Yes, exactly.
Okay.
That last tag is just saying, I want an interactive session with PowerShell. But you could do, the only ones I've used and seen are either cmd.exe or PowerShell.exe, but feasibly, if there was another command line interface or some tool in that image, you could start it. Like, I don't know.
Does it have to be command line? Can it be interactive?
Well, in this case, it would have to be command line because that container is running Windows Core, server core.
All right.
But it seems to me that if it were a graphical container, like a Windows server with a GUI container, you could have it start Explorer or Server Manager or anything, really.
I'm wondering on like the client side, if you said, hey, I want to containerize Chrome while I go research this thing, but I don't want to contaminate my box, hopefully. I'll just spin up a container with Chrome and do my surfing, close it out, and everything's destroyed.
Yeah, that's what you'd do then. You'd reference your image that has Chrome on it, and then because the executable is Chrome, isn't it? Chrome.exe, you would add Chrome there. That'd be worth testing out. These supposedly spin up really, really fast under Linux, Unix. Like I said, under Server 2016, and then when you add the latency of Azure, it takes a little bit longer. But let's run line 49. And like I said, that should, although it's not. Okay, I think I know what the problem is. I'll have to run this on the Windows Server machine that's in the cloud. Let me bring up my RDP session again. Docker run the name, I'll call it IIS demo 2. I want an interactive session. We'll do our port mappings again. Well, we've already got another VM running on port 80. Let's try 8080. Windows Server Core IIS was the image, and we'll have it start PowerShell for us. Syntax error. -P 8080:80. Let's see if that works. I already have a container with IIS demo 2. And let me say IIS demo 222. That should be unique. All right, so right now on that cloud-based Windows Server 2016 machine, Docker is taking that image and spawning a new container running IIS, listening on port 8080, and we should connect interactively to that container once it's up in a PowerShell prompt. Like I said, it's not just, Jeffrey Snover will tell you himself that they haven't optimized the code for speed at all, and that certainly shows.
Has Docker added any of the like orchestration type abilities to it yet? Because I know a while back they didn't really have anything that would tie, like, you know, bring up one thing and it already have all the things to tie all the other containers together. You had to have like another layer, something else to do that. I can't remember.
I don't think they've gotten that far with it yet. Yeah, I think at this point they're working on just the core.
Well, I mean, just Docker in general, not necessarily the Windows core.
Oh, in general, gosh, I don't know. But that is room for development, isn't it? The idea of making it easier to build Docker images that bring in multiple services. Is that what you're thinking about?
Yeah, so like if you have your developer environment that's like 5 servers, it comes up already knowing how to talk to one another. I think I heard they were working on something. I hadn't really followed Docker that much.
Mhm. All right, where are we in this prompt? Well, we are in a new PowerShell session. Like I said, there's no direct indication of whether we're in the container or the container host, because if you run host names, you'll see in just a second, it still says container host. If you do a dir, what is it giving us here? It's giving us, looks like it put us in a profile folder. What IIS, what's the default directory? Is it C, inetpub, www root?
I think probably an easier way to do the container to do a Chrome would probably be to do a Linux container with Chrome in it on like VirtualBox, and do like Vagrant locally or something. Because I mean, you just pull it up and then you can just destroy it right immediately after. And just bring it back up right after you're done, whenever you want to use it again. Because the Linux ones are just get those VMs so small. The Linux one and Chrome will run on it.
Huh. Weird. I can't really explain what's going on. It's got us jailed in the user profile folder. It's not allowing me to look at the root of drive C.
Would that tell you that you're in the container?
No. If you run a host name, it says container host 1, which is the name of the VM, not the container. I think this speaks to a weakness we identified earlier, isn't it? And it's not that they're really, unless we're missing something, it's entirely possible that I'm missing something, but it's not clear at all, really, where we are in the hierarchy. It's hard to visualize it. Wonder if there's
a unique identifier, like if you were able to look at, I don't know, if it's got WMI, or you can kind of look at like maybe the hardware ID or something if they associated with it.
It might even be something as simple as environment variable.
Yeah.
It might be an environment variable set.
True.
Yeah.